Welcome back to Maths with Mrs. J. We've started a series of videos about differentiation. At the moment, we're just concerned with polynomials. However, we will add different functions as we learn them, such as trig functions. In our previous videos, we were differentiating from first principles. Let me just stress that normally you would not do that as your method for differentiating unless you are asked to do so. Clearly, that is a fairly long-winded way of doing it. However, it is important to understand where we get our formula from and how we get the instantaneous rate of change using the limit. What we did find in our previous videos was that if we had a function y equals x squared, we came out with a derivative of 2x. In general, our rule is that if we have a function y equals f of x, doesn't matter whether you use it in f of x notation or y notation, if it's some constant times x to the n, as long as n isn't -1, then the derivative will be, well, the a just comes along for the ride. The constant just gets multiplied through. What we do is we bring our index down as a multiplier and we decrease it by 1. Let me show you, and I also want to just introduce you to the different notations that you use. If you're given y, quite often for the derivative you will write dy dx. Occasionally you might write y dash. Either of those is fine. Just going through the rule, we bring our index down as our new multiplier and we decrease our index by 1. Of course, if you've got a 1 there, you don't have to actually write it, do you? So the derivative of x squared is just 2x. Okay, if we've got f of x, so we've got it in function notation, so let's write our derivative in function notation. So the rule says we bring our index down as a multiplier and we decrease that by 1. We bring this down as a multiplier, but in this case we've already got a 2 there, so it's going to be 2 times 2, which is 4. And we decrease this by 1, which is just 1, so we don't need to worry about writing that. Okay, I'm going to use y dash here just for something a bit different. Bring this down as a multiplier, so 2 times 3 is 6. Decrease it by 1. Bring this down, so -3 times 2 is -6. Decrease it by 1. What happens when you have a 1x? Well, this is really 1x to the 1, isn't it? So you're going to get 1, then you're going to get x to the 0. Now, x to the 0 is just 1. So what actually happens is whenever you have just some constant times x, you're just going to get that constant as your derivative. And what's going to happen here with our -9? Well, this is really x to the 0. When we bring that down and multiply, we get 0. So the derivative of a constant is nothing. Thinking back to our straight lines, if we had y equals k of x, it's meant to go through the origin there, we have a constant gradient of k, don't we? And if we had a line that was just y equals k, that's just a horizontal line going through y as k, and horizontal lines have gradient 0. So just trying to sort of remind you that derivative is really talking about gradient. It's just that of a curve, obviously that gradient is constantly changing. Of a straight line, it is constant. Okie dokie. So let's just get rid of this. Okay. All right, let's get back to our question then. So we had this here, that's just going to be 1. So y dash is going to be 6x squared minus 6x plus 1. So that's a good thing to remember. If you just have a constant times x, it's just that constant as the derivative. If you have a constant and you differentiate, you get nothing. Okay, let's do the next one. So g dash x, differentiate 3, you get nothing. Negative x is really negative 1 times x. So we're just going to get negative 1. This would be a straight line if we were graphing it, wouldn't it? That's like y equals negative x plus 3 in your mx plus c notation there. So it makes sense that we have a constant gradient there. Okay, dy dx. Bring your index down and decrease it by 1. Multiply, bring it down, so you're going to get 4x to the 1 and then plus your 7. F dash x notation here, we're just going to get 2. Again, that's just a straight line if you graph that. That's in the form y equals mx plus c. This one here, dy dx, okay, bring your index down to multiply and we get 12x squared plus 4x, and we get nothing from the 7. And h dash x is, okay, multiply it down, decrease it by 1, and there you have it. In our next video, we're going to deal with situations where we have negative indices and fractional indices. So stay with me for that one.